Good morning, friends. In the last session, we focused on the fundamentals in programming language and the creation of Java language. We have seen the complete history of programming languages, right, along with the Java language. And I posted the second video, right, in which we need to discuss, the Java programming language, right, the important features of Java programming language, the security and portability features are discussed in that slide. Have you all gone through that slide? Second video, right? Have you all gone through that video?
Yes, sir. I have gone through the video you have shared yesterday.
Okay, very good. Today's
Yes,
session is a
sir.
live session, so I am recording the session. Uh, in this session, right, we focus on the features of Java programming language, right, and the versions of Java programming language. Let me share the PPT. Is it visible?
Yes, sir, it is visible.
Okay. In the second video, we have discussed the important features of two important features of Java programming language, security and portability, right? Anyhow, right, again, right, we are going to see, right, those features with the complete features of Java programming language. So other than the applets, right, another one, right, the topic servlets is also an important topic in Java, right? Applets are extending the complete functionality of a web browser, where servlets are designed to extend the complete functions of a web server, right? So more about applets and the servlets, right, we will discuss later, right, in the coming chapters, right? Now to enter into Java, right, first we need to go through the various features of Java programming language. Now let us see the complete features of a Java programming language. 1 minute, let me open my notepad. Today's session, right, the topic is features of Java. There are different features of Java. First one is simple, right? Java is to be a simple language, right? Because of its simplicity. Since Java is a high-level programming language, right? Most of the syntax, right, are completely derived from its base languages, the C and the C++. Since Java is a pure object-oriented programming language, the concepts of object-oriented programming are completely derived from the basic C++ language. And syntax-wise, for example, if you say a for loop, right, for, then initialization, then second part, conditional checking, then the third part, right, variable modification part, then opening the libraries, set of statements, closing the for. So syntactically, there is no such difference, right, between C, C++ to Java, right? And another one, right, how Java is to be or why Java is a simple language means the learners can learn easily, right, the language Java because, some of the difficult concepts, right, even from C and C++, right? Can you mention, right, anyone difficult concept in C or C++? Anyone difficult concept in C language?
Sir, pointer,
Very
pointer.
good. Yeah, very good. Pointers, right? Pointer, right? What is a pointer, right? Pointer is a variable which can hold the memory address of another variable in the system memory. For example, if you write int x is equal to 90, then another one int pointer p. Here, a p is a pointer variable, right? Which may point right to the memory address of its own data type, right? Same data type. For example, I can write p is equal to ampersand x so that the variable x, right, this is indirectly accessed using the pointer variable star p. So mathematically, right here, both the x and star p, right, are pointing the same value, right? So pointer, right, this is one important concept in a C language, right? There are different types of pointers, right? While pointer, right? Typed up pointer, null pointer, right? Pointers and arrays, right? Pointers and one-dimensional array, pointers and two-dimensional array, pointers and three-dimensional, multi-dimensional arrays, then pointers and functions, pointers and structures, right? So these are some of the right difficult concepts, right, from the C language. So pointer concept, right, is completely eliminated in Java, right? So the first important point is Java does not support pointers concept. This is an important point. Second one, right, in case of C++, can you find out any difficult concept other than pointers, right? Pointers are basic, right, both to C and to C++. Other than
Binary
pointers,
stack and the other one.
not one, other than pointers.
Stack and queue.
Could not hear you.
Stack and queue.
Stack, right? Stacks, right? That is some kind of right data structure applications. That's not difficult one, right? Without pointer, you can also implement, right? The stack applications using arrays also. I mean, right, in C++, right, in object-oriented programming, right, objects, classes, right, encapsulation, inheritance, polymorphism, right, dynamic binding. In that, right, one important concept is polymorphism. In polymorphism, right, you are having two kinds, right? One is a compile time polymorphism, that is a yearly binding. Second one is runtime polymorphism, that is a late binding. Can you give examples of compile time polymorphism? Examples of compile time polymorphism. Have you studied C++ language? Say yes or no.
Function
Overloading.
overloading.
Yeah.
Overloading, sir.
Overloading, sir.
Method
Function
overloading,
overloading.
sir. Method overloading.
Yeah, function overloading, right? Actually, in C++, function overloading, right? And another one is operator overloading. Operator overloading. Operator overloading. That is also one example of a compile time polymorphism, right? For example, right, I tell you, suppose a sample is a class, right, having three objects, S1, S2, S3, with respect to C++ implementation. Assume the class sample, right, consists of, say, two integer variables, say, int x comma y. Now, if you write that statement S3, right, which is equal to S1 plus S2, semicolon, what is the meaning? You want to overload the contents of two objects, say S1 and S2. Two objects S1 and S2 are added, right, content wise. So we are expecting, right, S3 dot x is equal to, we are expecting S3 dot x is equal to S1 dot x plus S1 dot y, and S3 dot, sorry, S3 dot x is equal to S1 dot x plus S2 dot x. Then S3 dot y, which is equal to S1 dot x plus S1 dot, sorry, S1 dot y plus S2 dot y. So content wise, right, the x and y, right, are added from the objects S1 and S2 and are stored into a new variable S3. So for that, right, what we have to do means we need to define a proper operator function. For example, void, right? Then class name is, for example, sample. Then scope resolution operator. Then what you have to do? We have to define an operator function, operator plus, right? This can be overloaded using two ways. One is a front function overloading, and another one is a member function overloading. Here you need to write, define, right, the proper parameters based on front function and member function. Then define the operator function so that if you write a statement S3 is equal to S1 plus S2, there plus is a polymorphic operator which calls the function operator plus, so that logically the contents of two objects S1 and S2 are added, right? And the result may be stored into a variable S3 based on a proper, right, return statement. This is the concept of operator overloading. There are several operators, right, to be overloaded, and some of the operators are not to be overloaded, right? We have to follow the rules of right front function as well as member function, right? Of course, this is one of the difficult concept in a C++ language. Now, coming to Java, right? Java does not support operator overloading. Understand? Only function overloading is supported. Java does not support operator overloading, and pointers concept are completely eliminated in Java. There is no star p, star q, star r, etc. Right? No pointers concept in Java. No operator overloading concept in Java. Right? So that learners can easily learn, right, the Java language. So the first important feature of a Java is simplicity. Right? Hope you understand. Second one is security. Java is said to be right a secure programming language. How Java is said to be a secure programming language, right? The second video I have explained, right? Java provides what kind of facility? Java runtime environment comes up with a facility called
Firewall.
Firewall.
very good firewall facility. The firewall right protects the runtime environment so that any unauthorized access, malicious access, right, will not enter into Java's runtime environment. So that when you download the applets and executing the applets, right, so that stage, right, what will happen means in a networking environment, right, your applet programs are completely safe, right? So no viral infections will affect into, right, the corresponding applet programs in case of networking applications. So for that purpose, right, Java is to be right a secured programming language. Third one, portability. This is said to be a portable feature. Java is said to be right a platform independent language. Compared to right the previous languages, right, C and C++, are not cross-platform independent languages, or not simply written platform independent, not platform independent languages. I have explained in the last video, right? For example, if you consider a file, let it be simple.c or simple.c++. After compilation, what is a file to be produced?
Executable file.
Very good.
Yeah.
Simple.exe, right? Even right based on the compilers, right? I have used right Turbo C++, right? TC Win45, right? You can find right a backup file, obj file, right? Those are automatically produced, right? So after compilation or running the file, right? What will happen means you will get the executable file. I have shown in that video without pressing Control F9, right? But after finding right the F9, right? After pressing F9, the executable file is produced, right? When we click that executable file, right, we are getting the equivalent executable code, so that the outcome of the program, right, will be displayed. So this is the case, right, in C and C++ languages. So simply, right, if you compile a file, right, what will you get means you will get an executable file, executable code or executable file. Where in Java, right, if you compile a Java program, say test.java, what is the name of the Java compiler?
Java C.
JRE.
Java C.
C.
Java C, yeah, that is the name of the compiler. The syntax is Java C file name dot Java, right? So when the file test.java, right, is going through the Java compiler Java C, right, we are not getting the executable file. Instead, we are getting
Bytecode file.
a
Bytecode file.
bytecode file will have an extension, right? Dot class, test dot class. Test dot class, right? You can see right the test dot class file, but you can see right different characters in that. we cannot recognize, right, or interpret anything from the bytecode file, because the bytecode file further will be interpreted by Java's interpreter called Java. So the syntax to run your bytecode file is Java file name. So in this case, right, you need to use Java test. Pressing Java test, right, what will happen means executable file, or you will get the corresponding output. In this case, right, a two-step process is explained. One is the compilation, and another one is running the bytecode file. The important thing in Java is, right, you can compile a file, right, wherever, right, in which whatever the operating system you can have, right. So if in case if you do not have the Java's runtime environment, right, no problem, you can only compile your file. If you want to install the JDK, right, you try to install JDK version 1.8, right, and you try to Google it in uh, Oracle download, sorry, Java download Oracle, right. It will take you to the Oracle site, right. There you can find the Java's latest version, and you can install two things. One is JDK and another one is JRE. If not, I show it later, right. You need to install both JDK and JRE. In case if you are having only the JDK, right, without JRE environment, right, you can compile your file so that test.class, right, is obtained. After that, right, in case if you consider your file test.class, right, if you want to run it in a different operating system, right, assuming that where Java runtime environment, right, JRE is installed, right, there JVM, Java virtual machine, right, which can have the corresponding interpreter called Java. There, right, the Java interpreter compiles the bytecode file, then it produces the equivalent executable file or output one. So in this case, right, that's what, right, we are saying that different operating systems or different platforms bytecode file will run. Bytecode will run in different operating systems. Only thing is that you need to install the Java's runtime environment, right? So that's what Java is said to be, a portable programming language. This is the portability feature of Java. Simplicity, security, portability. Fourth one is object oriented, right? Object oriented. Java is said to be a fully object oriented programming language. I explained already, right? Where the C++ is said to be partially object oriented programming language, because you can write a C++ program similar to a C program using a top-down programming approach without classes and objects. In case of Java, right, you need a concept at least a class, right? A class, right? For example, sample. Within the concept of class, sample, right? Here you need to code it. So what is class? Class is a object-oriented programming concept. So without having the concept of this one, a class, right? You cannot write a Java program. That's what Java is said to be, a fully object-oriented programming language. Fifth one, right? Robustness. Java is said to be a better improved language compared to C and C++. Improvement over C and C++. Because certain features in C and C++, right, are to be compared in Java, right, we will get a better enhancement, right, over C and C++. To understand, right, how Java is having a better enhancement over C and C++, right, we can consider some special cases, right. One is memory management mistakes. Memory management mistakes by the user. In C language, right, you might have seen, right, the different memory allocation functions. Can you point out the memory allocation functions?
MLOC.
log.
MLOC, CLOC.
log.
Yeah, MLOC, CLOC, right? Then you need to use right delete or new operator, right?
Yes, sir.
Reallocate, and even in C++, right? Better way to handle the memory management is using constructor and destructor. Inside the constructor, you need to allocate a memory, and inside the destructor, right, you need to deallocate the memory, right? In case of Java, right, there is no concept of destructor, right? No destructors in Java. This is important point we have to note it. Java does not support destructors, right? So better way, right? This is improved. I tell you, right? As far as right memory management is concerned, right? Whenever the user right allocates a memory, for example, in C++ point of view, I say inside the constructor, right, you need to use the operator new, right, to allocate a memory. A character pointer is equal to new of 10, like that, right? If you use a new right to allocate a memory at the end, right, the user should be responsible to deallocate the memory, that is to free the memory using the delete operator, delete function, right? So new right can be placed inside the constructor, and the delete operation, right, reallocation, deallocation can be mentioned in the destructor, right? In case of Java, right, the memory allocation is explicitly done with the help of new. Understand? New is supported in Java, right, to allocate a memory. Where there is no delete because Java does not support a destructor concept, right? Here, the deallocation is completely an automatic one that is done with the help of right, a default garbage collector, right? GC garbage collector periodically checks if there are any unwanted objects, right, available in your current application, right, the garbage collector automatically right releases the allocated memory. So that's what, right, no destructor is supported in Java because of complete or automatic deallocation of memory supported in Java. Understand or not? So you need not worry about, right, the destructor concept and the deallocation concept. Wherever you want, you can allocate a memory, right? And you need not worry about, right, deallocating or deleting the allocated memory. So that's what compared to C and the C++, right? Java is a better enhancement language with respect to memory management mistakes made by the user. Another one is handled exceptional conditions. Is handled exceptional conditions. In C++, right, you might have seen, right, there is a topic on exception handling, right? For example, if you write a statement int x is equal to 10 by 0, semicolon, we cannot divide the quantity, right, integer, right, 10 divided by 0. 10 by 0, right, it cannot be evaluated, right? This results in exception. What do you mean by exception? Exception means runtime error. Exception means runtime error. So during the runtime, right, there will be no compilation error, right, when executing int x is equal to 10 by 0. But at the runtime, right, the problem to be faced is this one: int x is equal to 10 by 0, divide by 0, error. Now, to handle this, right, you need to properly introduce, right, the keywords, right, in C language, in C++ language, right, you might have seen, right, some of the keywords, for example, try, right, keyword, right, that should be enclosed within a proper block, right, and you need to handle the corresponding runtime error, right, a code inside the exception handler or inside the exception block. Where in case of Java, right, Java provides a flexible way of handling the runtime error using the keywords try, catch. Remember that, right? These are the keywords in Java. Try, catch, throw, throws. Finally, Java completely supports object-oriented exception handling framework. So using Java's object-oriented exception handling framework, right, we can design a program, right, so that the program will be protected from, right, the corresponding runtime error. So within a try block, right, you can place the statements, right, the statements which are monitored against the runtime errors. And inside the catch block, right? So what kind of runtime errors may be reported? Those can be caught right inside the catch exception and right. Likewise, throws and finally, right? In the later chapter, right, we will explore more about object-oriented exception handling with the help of some predefined exceptions, and we can also define right custom user-defined exceptions. So mishandled exception conditions can be efficiently handled in Java using the flexibility of object-oriented exception handling. Compared to C and C++, since these features are additionally supported, we can say Java is a better, improved language. Understand? Any queries? Then another one is multi-threaded. Java is said to be a multi-threaded programming language. Right? There are two important things, right? One is multitasking, and another one is multi-threading. Thread means a single flow of execution, right? Multi-thread means right more than one flow of execution. Multitasking means right all operating systems, right? Support right this multitasking capability. For example, right, I am using right Windows 10 operating system. So in Windows 10 operating system, right, I can execute right more than one applications, more than one applications. Currently, I am working with the Notepad. At the same time, right, I can play right some audio file, right? So audio file, right? For example, using some tool, right? I am playing the audio file. So that is a second application. At the same time, right, I am connecting right the program, for example, Java programming.txt to the printer. If I use right printer, right, then the application right will be connected with the corresponding printer one, right. So at the same time, right, I can execute another application. I can check for right scanning the viruses, right. So using the tools. So more than one applications run concurrently, right, or run parallel, right. That is a concept of multitasking. Java's aim, right, is to support right multi-threading. Thread means right thread means a single flow of execution. Multi-thread means more than one part of same program. We can ask, how is it possible? That is possible in Java. Java supports multi-threading. For example, a program consists of some methods. Professionally in Java, right, the term methods is introduced, where in C, C++, we are using the term functions. Suppose M1, M2, etc., right, Mn are n different functions, right? You can n different methods, right, in Java, right? You can execute right several methods, right, concurrently using a single processor, uniprocessor, single CPU, right? So that is possible in Java. For that, right, we need to have right the predefined right packages, right, using the thread class and using the runnable interface, right, facilities. We can write a multi-threaded program so that more than one parts of the same program, right, run right concurrently. That is the concept of multi-threading. More about right exception handling and multi-threading, right, we will explore right in the coming chapters. Seventh one, the interpreter and high performance. Java is said to be an interpreter language, right? Because of its bytecode feature, right? Java's designers felt that, right, to design the language, right, that should be portable in different operating systems or in different platforms, right? So the architecture neutral goal of architecture neutral goal of Java was write once, run anywhere, anytime, forever. Understand the meaning of this goal? Write once, run anywhere, anytime, or forever. Write once means, right, you can write a program, right, only one time. For example, test.java in any one operating system, for example, X operating system. Run anywhere, right, in the sense that, right, once you compiled, right, to produce a bytecode file, test.class, the test.class, right, will be running in different operating systems, right, anywhere, that is the meaning, right, Windows 95, 98, right, 2000, right, 7, Windows 7, right, Windows 10, XP. So whatever the operating systems, there you need to install the Java's runtime environment so that the program, the bytecode file, test.class, right, is interpreted by the Java interpreter. Anytime, you need not have the original file, test.java. Just test.class is enough, right, to interpret the actual content of test.class. Forever, right? So any number of times, right, you can run your file, test.class. That is the architecture neutral goal of Java. Write once, run anywhere, anytime, and forever. Then hype one, interpreted and high performance. Another one is distributed and dynamic. Java is to be, right, a distributed programming language. Java works in a distributed environment. For example, in the case of networking applications, right, a concept called RMI, remote method invocation, right? So using RMI, right, for example, we are working on a client side, right? A server is there. From the client, right, you can send a request to the server, right? Server can, right, respond to the corresponding client request. So using remotely, right, objects can interact each other from client to server, server to client. So Java works in a distributed environment. And Java is also said to be a dynamic programming language. As we have seen in C++, right, dynamic binding is supported. Dynamic binding. What is dynamic binding? Code associated with the function call, right, can be determined at later time, right? So later time means runtime. In case if you are using inheritance and virtual functions, right, using the keyword virtual, base class is there, derived class is there, functions will be made as a virtual function. Base class, right, you need to define, right, the base class object pointer, right, then derived class object, right? So pointing the objects, right, using the object pointers, right, you can call the versions available in base and derived classes so that, right, runtime, right, which is a right function to be determined, right, is to be called. That is a concept of runtime polymorphism. C++ achieves runtime polymorphism using both virtual functions, right, and inheritance concept, right. Java also supports runtime polymorphism, right. So simply Java supports runtime polymorphism, right, without any pointers concept, right. That is further important one. So Java is said to be a dynamic programming language, right. So remember that simplicity, security, portability, object-oriented, robustness, multi-threaded, interpreted, and high performance, distributed and dynamic, right? These are the major features of a Java programming language. Having any queries?
Sir, once can you explain multi-threading, sir?
Multi-threading, see, multi-threading means more than one part of the same program is going to be executed, right? So in short, right, I explain multi-threading now, right? Later, right, we focus on right multi-threading in detail. For example, in one program, right, having some two methods. Say one is M1 is one method. Just consider another method, right? Some statements are there inside that, right? Just assume M1 is one method having some statements. M2 is another method having some statements. Both methods are defined in the same program, right? During the runtime, both methods are going to be executed concurrently. That is important. So concurrent in the sense that we are not using multiple processors. Only one CPU. Only one CPU is used to execute, right? Methods M1 and M2, right? Suppose M1 is executing, assuming that 5 statements are executed. After that, what happens? A keyboard input is required to execute the next statement in M1, right? After some time, the keyboard input is required, assuming that some input x comma y comma z. That time, right, what will happen means you need to input a value, right? So while you input a value to the method, say M1, right, what will happen means your processor will become idle. Understand? Your processor will become idle. So to minimize the processor idle time, right, and to maximize the CPU utilization, that means to maximize the CPU utilization, right, while the processor is idle, right, you need to transfer the control to execute some statements in M2. So that stage, right, control is automatically transferred to execute the statements inside the method M2. So thereby, right, you are reducing the CPU idle time and you are maximizing the server utilization time. So from M1 to M2, control is transferred, right? So after executing some statements in M2, right, then control again comes back to M1 to execute the next statement, right, in the sequential order after where the last statement is executed. Then after some time, right, if there is some interrupt in M1 or M2, control is transferred to execute some other methods, right? So this way, right, CPU utilization is increased, right? Thereby, Java's multi-threaded environment, right, supports to execute more than one parts of the same program concurrently. Hope you understand the meaning concurrently. Clear?
Yes, sir. Thank you, sir.
Okay.
Yes, sir.
Okay. Then, right, these are the features of Java language, right? Then the evolution of Java, right? You try to go through these different versions, right? Initial version was Java 1.0, right? Then Java 1.1 is introduced. Then Java 2, right? 1.2, right? In between, right? You can find, right, these different editions, platform standard editions. Then J2SE, right? After some stage, right? Java 2 standard edition, right? J2SE 1.3, 1.4, 1.5, 1.6, 1.7, right? 1.8, like that, right? It goes on. Then latest edition, right, you can find JDK 11 corresponding enterprise edition is standard edition. This one standard edition 11, right? Then latest, right, you can find, right, Java standard edition 14. In that, right, version is 14.0.2, right? That is the latest release of Java standard edition, right? The platform given in the Oracle site. You try to go through, right, the different evolution of Java, right, from one version to another version, right. Some features are extended. So with this, right, we are completing the today's session, right. Now this is a time for interaction session, right. If you have any queries, you can ask, right. Otherwise, right, I will be moving on to, right, solving some MCQs. You try to use, right, Java's, right, a complete reference 11th edition. I have posted in the platform in Google Classroom, right? You try to go through that, right? Latest edition, 11th edition. Having any queries in the fundamentals and futures of Java. Java is really a nice language to learn, right? Because of not supporting the features of, right, pointers, right, destructors, right? Some other enhanced features are there compared to C and the C++. So syntax wise, right, the language is right easy to learn. This is a time for you. You can ask your queries. Any queries? Is the book you shared consistent with the syllabus? Yeah. What is your syllabus, right? Your syllabus follows, right, 11th edition. I show you the syllabus, right? Please go through that. Java programming, complete reference Java, right? 11th edition is mentioned in your syllabus. So go through that syllabus, right? The complete reference 11th edition, and try to install the latest, right, JDK environment. Okay, so I ask you some queries. Can you give examples of platform independent languages?
Sir, Java and Python are platform independent.
Java, then you can say, right, C sharp, right,
Sir.
VB.NET, C sharp.NET, right? Those are cross platform independent languages. Another question, right? Java's interpreter, right? We can say, right, what is the name of Java interpreter?
JVM, Java Virtual Machine.
Java virtual machine, right, which consists of the interpreter Java, right? Java is actually the interpreter name that we are going to use it in the command prompt. So using Java, right, assuming that we are having some XLOC lines of code. During the compile time, right, the files are compiled, right? Assuming that, right, is the compiled files are stored in a name, say y, some y dot class. Y dot class, right, can have, right, several compiled code for the classes and the interfaces. Now during the runtime, right, focusing on runtime polymorphism, when we are going to call a particular method, that stage, right, will Java interpret all bytecode files to execute a single method? Can't you understand my question? Having several methods, right? All methods are compiled into a bytecode file. But during the runtime, right, you are calling some specific methods. You are not calling all the methods. However, all the files are compiled. So that stage, right, JIT compiler, right? We said in the earlier class, just-in-time compiler, right? So just-in-time compiler, right? That facility, right, compiles the code that is only necessary for the current execution, right? So that is an important feature of JIT. Just-in-time compiler compiles the code, right? Only necessary for the execution, right? All files, right, will not be right compiled and interpreted, right, during the runtime. Then any other queries? What is the difference between JRE and JVM?
It is for security and the other is for portability, sir.
Java runtime environment, right? That's Java virtual machine, right? Both are right synonymous, right? In Java runtime environment, right, we have a facility of JVM, right? JVM, right? That is a route to compile, right, the corresponding Java programs. JVM and JDK, what is the difference? JVM, right, very good to compile, right, JRE runtime environment, having the interpreter to interpret the bytecode files to run it. JDK, Java Development Kit, the complete runtime environment along with the development tool is said to be JDK, Java Development Kit. JVM is executable. JVM is used to execute the bytecode. Okay, now I ask you write some more questions. Notepad visible. Answer the first one. Which of the following option leads to the portability and the security of Java?
Option A.
A, sir.
Option A, sir.
Option A, sir.
Bytecode is executed by JVM.
Yeah, bytecode is executed by JVM. That is the main feature for
Option A.
the portability and security. In case if you want to have the specific security feature means with the help of applet, right? A security is possible, but bytecode is responsible, right, to achieve the portability feature. Bytecode is executed by JVM.
Use
C, sir.
Use of
Option C.
pointers.
Option C, sir.
Java feature. Use of
Java
pointers.
does not support
Option C, use of point.
third one.
JRE. JRE, sir.
JRE, sir.
Are you sure?
JRE, sir.
JRE Java runtime environment that is used to interpret the bytecode file. The question is right how to find and fix the bugs in the Java programs. For that, the Java's facility right comes up with a tool called JDB. JDB is to be Java debugger, right? Java debugger, right? This is a command line option. Hope you understand. Using the DOS prompt, right? You can use these things, JDB options, class arguments, right? The purpose is, right? This can debugs the corresponding class, right? That you need to mention using the syntax. For example, JDB my class, right? So if there are any bugs reported in this, right? This can be right resolved right using the Java's command line debugger called JDB. JDB, that is a Java debugger, right? Command line debugger, right? That is the correct one. Finding and fixing bugs. In case if you want to write a compilation, that is different from right? Finding and fixing the bugs. In compilation, right? Syntax errors are only to be reported, right? So if you want to find out some other bugs, right? Using a command prompt, the tool to be used is this one, Java's JDB, right? So more about JDB, right? So go through this Oracle documentation. Then fourth one, which are the following is a reserved keyword in Java? Reserved word, right? A keyword in Java. Which are the following is a keyword in Java, a reserved word in Java? No idea?
Option D. System.
D, sir.
Uh,
D, sir.
System. C, D or B? Strict FP. Which one are you pointing?
Option C, sir. Main.
See, main is actually a method in Java, but main is not a keyword in Java. Strict FP.
System, sir.
No, see, I tell you, right? Capital O, right? Object,
C,
right?
C.
That is a built-in class. Then main, right? Nowhere related as a keyword, right? Main is just main method name, right? Method name. Method names are completely different from keywords in Java. There are several differences from method names and keywords, right? Method names are not keywords. A lot of methods are there. So if you say, right, those methods are keywords, right, it will go right in a number of pages, right? So this is not a keyword. System, capital S, right? That is a class, but this is not a keyword. Only strict FP. FP is a floating point. To restrict, right, some a floating point value of a variable, strict FP keyword is used. Okay, strict FP is the correct one. JAR. What is Java?
Java archive.
D, sir. Option D.
Option D.
Yeah, Java archive files, right?
Option D.
Yeah, to archive, right, the files in Java. Sixth one. How classes and objects are dependent on each other. Normally, right, classes and objects, you can have several methods in the class, right, and you can call the methods, right, using the objects, right. Objects and the classes are normally, right, tight coupled, right. So tight coupling is the answer. Seventh one, which of the following is not a hook concept in Java?
Polymorphism.
What you?
Compilation.
Polymorphism is a key concept in Java, right? Polymorphism
Compilation.
is a key concept in object-oriented programming. Both the compile time and the runtime polymorphisms are supported, right? Compilation is not actually
Compilation.
a concept. Yeah, not actually a hook concept.
D, sir.
Yeah, it's not even a hook concept. Eighth one, which of the following is a type of polymorphism in Java?
Compile time polymorphism.
Yeah, compile time.
Execution time.
A, sir.
Yeah, compile time correct. Execution time, if you mean interpret the board as runtime.
Option B, sir.
Both compile time and the runtime, right? Option A, as far as right, you can assume, right? Compile time polymorphism, unless stated explicitly as runtime polymorphism. But both polymorphisms are supported in Java. When is method overloading determined?
B, sir.
Yeah, compile time polymorphism, right? I said you. Examples of compile time polymorphism are function overloading, operator overloading, where operator overloading is not supported in Java. After the first public release of Java, right, it was targeted at
D, sir. Internet development.
very good internet development. Which concept of hook is a way of converting real world objects in terms of a class?
Option B, sir. Encapsulation.
Converting real world objects, right? In case when we have, right, more amount of real world objects, right? If you want to convert, right, encapsulation means that can be encapsulating the entire, right, attributes and methods, right? But you can write simply, right, give an overall idea means abstraction is the correct one. Abstraction will give you the overall way of, right, converting real world objects in terms of a class. In abstraction, no detailed implementation will be given. How a method is going to be implemented, right? That can be hidden in abstraction. 12th one.
A, sir. Encapsulation, sir.
Encapsulation,
A.
sir. Option A.
Encapsulation. Then method overriding is a combination of inheritance and polymorphism. I said right with respect to C++. C++, to achieve a runtime polymorphism, we need right both inheritance and virtual functions concept. Right, in virtual functions concept, right, you need to have what kind of polymorphism? Compile time polymorphism, right? Method overloading, right? So two methods are same, right? Both in base and derived classes. Using the keyword virtual, right? It determines at the runtime, right? What kind of method is going to be called. So method overriding is a combination of inheritance and polymorphism, right? That is true. More about right method overriding we will explore, right? Which component is used to compile, debug, and execute Java program?
Yes, sir.
Option B, sir, JDK.
B, sir.
Execute a Java program, that is compiling, debugging, right? Java virtual machine, right? Using Java C. Java C something, file name.java. That is a way to compile, debug, and execute. JRE, right? Runtime environment only to execute, right? So compilation, debugging, and execution, right? Performed with JVM. Which component is responsible for converting bytecode into machine specific code?
JRE.
Very good. JRE, runtime environment. Which component is responsible to run a Java program? Running a Java program, right? That means we are compiling, executing, right? So basically we can say virtual machine.
Yes, sir.
Yeah, all the functions are right related, right? Running right a virtual machine because it supports Java's interpreter, right? Runtime environment comes up with Java virtual machine, right? All are interrelated. Which component is responsible to optimize bytecode to machine code?
JVM.
Yes, sir. JVM.
JRE, sir.
JVM, sir.
JRE.
JRE, sir.
No, I clearly said just-in-time compiler compiles the code, right, which is necessary to execute. You can have several methods. You are calling right two methods, right? So just-in-time compiler optimizes the bytecode to machine code. JIT is responsible. To try to write Google JIT, right? We will see that, right? The actual functions of a JIT. Then 18.
Yes, sir.
Platform independent programming language.
Independent programming language. 19th one. Okay, in Java,
Java file.
public static void main, right? That is a syntax to define main method or static public void.
Private, sir.
Private.
Java extension is Java files are extended with
Java.
Not Java. Not Java.
compiled Java classes can have an extension.
Class.
Dot class.
Not class.
Interpreter role is
Bytecode to machine.
Option A, sir.
Option
Bytecode
machine language.
Bytecode to machine language.
okay. Let me explain. With respect to Java interpreter, you can say Java interpreter converts the bytecode into the machine language code. Have you studied Pascal or heard about Pascal? Pascal is an interpreter language, right? Pascal is an interpreter language. So in Pascal, you are writing a high-level code. High-level code is executed by, right, the interpreter, right? So in general, right, the interpreter uses reading a high-level code and executing them. As far as Java is concerned, Java interpreter interprets the bytecode into machine language code. So option B is the correct one. Java source code is compiled into
Bytecode.
Bytecode.
Sir.
Bytecode, sir.
to compile a Java code. We need to use
Java C,
Java
sir.
C.
Option B.
Java C. To execute a Java code, we need to use the tool
Java.
Java, sir.
Java.
how Java applet classes are hosted.
Applet viewer.
Applet viewer, sir.
Given.
Applet viewer, sir.
Viewer.
HTML based documentary help can be accessed using
Java doc.
Yeah,
Java doc, sir.
Programming was designed by
Sun
Sun
Microsystems.
Microsystems.
Sun Microsystems.
Microsystem.
beginning Java was provided in order
Create strong programming alternatives.
Operations on internet.
to connect many household machines. Java was created
Oak.
okay, with this
Oak, sir.
yeah, very good. Let us wind up the session. Okay, thank you very much.